All right, this is Pascal triangle 2. So, given an integer row index, return the row index if row of the Pascal's triangle. In Pascal's triangle, each number is the sum. Yeah. Okay, that's an interesting spin. Let's see an example. Let's see if it makes more sense. So we're given the row index, which is 3, and the output is 1, 3, 3, 1. Because in the 0, 1, 2, third index, that is what we have. Interesting. So just like the first Pascal's triangle, I think we're gonna need to, create the Pascal triangle, but we can stop at where said row index is. So, oh, actually, this, yeah, we're leading up to that. That's it. That's interesting. So we can iterate this many times, and I guess once we're at the end of the iteration, we just return what that output is. There has to be a spin to this. That will be O of n squared because we have to create all these rows. I wonder if there's another way. Let me think for a second. So is it crazy that row of index is 3 here? Let me reset this. Row of index 3 is 3, and then the output has, 3 in it. Same for 2, and I guess these don't count, but 4 also has it. And then once we get 5, 5 will also have it because 1 plus 4 is 5. I wonder if we can use that to our advantage. Like, that should actually give us enough to just build that output. So I'm thinking like, I'm thinking, given the row index, oops. No, thank you. Oh my God. Row index plus 1 is going to be the length of our output. Is that always true? Yes. 4, 5. Yeah. And then we can find the middle of this, which in this case is 1.5. Do we floor or ceiling it? Not sure yet. But as we're iterating, the first number will be 1. The second number will be the row index. And if we've reached our middle, in this case we have, we can just reverse this. Oh my God, would that work? That'd be crazy if that works. So let's try this one. So we have a row index of 4. The length will be a 5. The half of that is 2. So the first one will always be 1. Second one will be the index. Third one is still, this index is still less than or equal to the half. The third one is going to be, what is it going to be? It's going to be 6, but how do we get 6 without having the previous array? I guess. Can we? I don't think we can. And if we did this one step further, if we did 5, for instance, like that would be 10, right? 1, 5, 10, and then 10 again, 5, 1. There's no way to calculate this, right? Without having that, unless it's the index plus half. Because 5, wait a minute. That can't be right. Half floored? Because this is, half of this is 2.5, right? Half floored would work. I'm exploring because I know that first option I said is going to be right, but I don't know if that's going to be the most efficient. So 1, then we'll have 6, and then we'll have 15, and then we'll have 20, and then we'll go back to 15, and then 6, and then 1. Yeah. So 1, because in the beginning, the index, that's not gonna work. 6, 3, 9. Yeah, I guess there's no other way to calculate these. Okay, then yeah, I think we just have to go through the first option I said. Bummer. I think we can start coding. So we're gonna have a result array again. Actually, yeah, we do. We're gonna have a result array. We're gonna want to iterate through the row index. 0, 1, 2, 3, third index. So in this case, it's offset -1, so we need to do +1. Row index is 3. We want 0, 1, 2, and 3. So once this is at 3, is 3 less than 3? No, but it's less than 3 plus 1. Okay. And then I plus plus. And then we're going to have that array. It's going to be that new array of size I plus 1. And we're going to want to iterate again in through that new array. And we want it to stop. New array is going to be 1, so 0. Yes, it's going to go at least once. And we're going to say if j is 0 or j is at the end, which would be new array.length -1, then we're going to assign new array of j to 1. Else, we need to do the calculation, which will be new array j equaling to the result of the previous, which is I minus 1. Yes. That value of j minus 1 plus the same thing of j. Okay. And then we will simply need to return. Well, first we need to push this result into the new array result into the result array that we have. And at the end, instead of returning result, we're going to return the last element in the result, which is going to be like that. Yeah, I think that will work. Is that the most efficient? We got accepted. Let's go ahead and publish it. See. Oh, wow. So beats 100%. Interesting. Okay. We'll go look at the solutions. Let's see a TypeScript one. That's what I'm using. 2 approaches. I love that. So interesting. They just end early. They make the triangle. Have the last row. Yes. and a new row. That's smart. They can just instantiate it, right? That makes sense. And they're just going to push and neural that push at the end because, yeah, that makes sense. They're doing the exact same thing we are doing, except theirs, I would say, is a little cleaner. I just want to see the second approach. Wow. That's impressive. I don't know what's happening. No, I do. They create the row, right? And then, oh, this is what I think they're doing what I tried to explain earlier, but I couldn't figure it out, which is, yeah, they start with 1 and then the row index. Yeah, they're creating that row. Okay, so how are they doing it? Row y minus 1. Okay. Oh, I kind of want to go through this. I have time, 4 minutes. Let's see. So if it was like 1, 6, what was it? 15, 20, 15, 6, 1. I think that's the 6th row, right? Because it would be 5 and 10, which would be, and then 10 and 10, which would be 20. Yeah, I think that's right. So we'll have a row. Let's see if you guys can see this. Have a row that starts with 1. Okay. And then starting at 1, let's say this is 6. Row that push, map that floor of row I minus 1, so 1 times row index minus I. Oh my god, so 6 minus 1, 5 plus 6 plus 1, 6 divided by I, which is 1. So it's 6. Oh wow. Times 1, 6. Okay. And now we're at I equals 2. So row I minus 1 is 1, which is 6. And then row index 6. Jesus, I'm freaking out. Row index. No! What? Oh my god. Row index. Can I get that back? Row index 6, which was I, which is 2, which is 4. This will be 5 divided by 2, which will be 2.5 times 6. 6 times 2.5 is what? What is that, guys? Oh my god. Oh my god, it's 12. 12 plus 3. It's 0.5 of 6. So that'll be 15. Oh my god. And flowing that. Oh my god, so that works. Okay. That's crazy. See, this is what I was trying to explain. And I couldn't do it. I always forget time complexity. So I don't think I saw it. So time complexity wise, yeah, I didn't see it. I mean, it's just like the other one. It's going to be n squared, right? Because we have to go through each row index being n. We have to go through each row, or we have to go through each row in the triangle and then each element in the row. So that'll give us n squared. But with that other solution, it's just O of n, right? Pretty sure it's just O of n. Ugh, gross. Approach 1, O of n squared. I was right. Approach 2 doesn't say, but O of n probably. Huh, cute. Cool. Thank you.